Tonight, we are going to drift all the way out into the true scale of the Milky Way, our home galaxy, and settle slowly on one quiet question. Out of a few 100 billion stars, where exactly are we hiding inside it? Right now, you feel perfectly still. The room is quiet, the bed is holding you, and the stars beyond the window have not stirred at all. But every part of that is a gentle illusion. You are turning, racing, falling through space at nearly 500,000 miles an hour, carried inside an enormous wheel of ancient gas and uncountable stars. And here is the quiet question we will follow all the way down into sleep tonight. That wheel, our Milky Way, is one of the largest galaxies in all the universe. It is also, somehow, a speck too small to mark on the map. Both are true at once, and hidden somewhere inside it, in a corner so quiet it is almost nowhere, is the small, warm world you are resting on. By the time the night is over, we will have found exactly where it sits, and why it may be the safest address in the galaxy. This is the first quiet strangeness of the night, and it is worth settling into slowly, because there is nothing frightening in it. You feel motionless. You are anything but. And the reason you feel nothing at all is the same reason a passenger on a smooth, high flight can pour a glass of water without spilling a drop. When everything moves together perfectly at a steady pace, the motion disappears. There is no jolt, no wind, no sense of speed, just the calm. So the stillness you feel tonight is real in its way. It is the stillness of something enormous moving so smoothly that it forgets it is moving at all. The thing we are turning inside has a name you have known since you were a child. The Milky Way. You have probably said the words 1,000 times without ever stopping to feel their weight. A galaxy. Our galaxy. A spiral of stars so wide that the words we use for distance fall apart inside it. We cannot measure it in miles. The numbers grow too long, too heavy. The line of zeros runs off the edge of the page and means nothing to the human mind. So we measure it instead in light. Light is the fastest thing there is. Nothing in the universe is permitted to move quicker. A beam of light could cross the entire width of the Earth in less time than it takes you to blink, going around the whole planet 7.5 times in a single second. From the sun, that same light takes about 8 minutes to reach your window. From the next nearest star, it takes more than 4 years. Light is, by every measure we have, impossibly fast. And here is the size of the thing we live in. That same beam of light, the fastest thing in all of creation, would need 100,000 years to cross our galaxy from one edge to the other. Not 100 years, 100,000. A length of time so long that when that beam first set out on its journey, there were no cities anywhere on Earth, no farms, no written words. Our ancestors were painting animals on the walls of caves by firelight. The beam has been traveling ever since, all through the rise and fall of every empire that has ever existed, and on a galactic scale, it would still be only partway across. That is the structure holding you tonight, somewhere between 100 billion and 400 billion stars, turning together in a disk so vast that light itself grows tired crossing it, and you are inside it, not looking at it from a safe distance, the way you might look at a painting on a wall. You are within it, woven into it, one of its uncountable passengers, riding a slow current through the dark. And this is where the gentle paradox of tonight begins, the one quiet question that will carry us through everything that follows. The Milky Way is, by the standards of the universe, a giant. Most galaxies are far smaller than ours, dwarfs of a few million stars, faint and modest. We are one of the big ones, near the top of the scale. And yet, set against the full reach of the cosmos, this same giant becomes a speck, a single grain among uncountable others, too small to even mark on the largest maps we can draw, enormous and tiny, both at once. By the end of tonight, both of those will feel true, and, stranger still, both will feel restful. But there is a second question folded inside the first, and it is the one I find the most beautiful. If the galaxy is this vast, then where exactly are we inside it? Not the center, it turns out. Not the bright and crowded heart of things. Somewhere quieter, somewhere safer. A calm pocket of space, far out along one of the lesser arms, where the stars are spread thin, and the nights are long and undisturbed. We are, in a sense, hiding, tucked away in the suburbs of a great city of light, riding a gentle gravitational current that has kept us safe for longer than the Earth has had oceans. So tonight, we are going to take the long, slow way through all of it. We are going to walk through the true shape of our galaxy, the parts the textbooks flatten and tidy. We are going to find our own address within it, the precise quiet corner where we have always lived, and we are going to feel, without any hurry at all, what it means to be a small and knowing thing, resting inside something so unimaginably large. There is nowhere to be, nothing to solve, just the dark and the stars and the slow turning of the great wheel we ride. Let your shoulders come down, let the bed hold you, and let us begin, gently, at the shore of the cosmic ocean. Most of us carry the same picture of the Milky Way in our heads, and we have carried it since childhood. It is the picture from the schoolbook. A flat, tidy pinwheel, seen from above. A bright round center, 2 or 4 graceful arms curling outward in perfect symmetry, and a small dot somewhere on one of those arms with an arrow pointing to it that says, "You are here." It is a lovely picture. It is clean and calm and easy to hold. And it is, in almost every important way, wrong. The real Milky Way is nothing like that flat geometric circle. It is not a diagram. It is not tidy. It is a living, moving thing made of gas and dust and starlight. And it is far stranger and far more beautiful than the schoolbook ever let on. To begin to see it as it truly is, the first thing we have to do is let go of the flatness, because our galaxy is not flat at all. Imagine a vinyl record, the old black kind, left out too long in the heat of a summer day. When you pick it up, it is no longer flat. The edges have warped. They lift and dip in a slow, gentle wave, so that the record is no longer a flat disc, but something softly twisted, like a wide-brimmed hat or the surface of a calm sea. Our galaxy is shaped like that warped record. Astronomers actually call it the galactic warp, and it is one of the great quiet surprises of modern astronomy. The outer edges of the stellar disk are pulled up on one side and down on the other, bent thousands of light years out of the flat plane we always imagined. For a long time we did not know this. From inside the disk, embedded in it, it is desperately hard to tell the shape of the thing you are part of. It took careful measurements of the positions and motions of millions of distant stars to reveal that the disk is not a clean plate, but a warped and rippling sheet, and once you see it, you cannot unsee it. The Milky Way is less like a coin lying on a table and more like a leaf floating on water, its edges lifting and falling with currents we are only beginning to understand. So where does the warp come from? What could possibly take a structure 100,000 light years wide and bend its edges out of shape? The answer is gravity and the patient pull of our galaxy's companions. Because the Milky Way does not drift alone through space. It travels with a small entourage of smaller galaxies, companions caught in its gravity, circling it the way moons circle a planet. And two of these companions matter most for our story tonight. They are called the Large Magellanic Cloud and the Small Magellanic Cloud. If you have ever stood under a truly dark sky in the southern half of the world, in the deserts of Chile or the outback of Australia, you may have seen them yourself. Two faint, hazy patches of light, low against the stars, looking almost like torn pieces of the Milky Way that drifted away. For centuries, sailors used them to navigate the southern oceans. They are not clouds at all, of course. They are entire galaxies, each one home to hundreds of millions or billions of stars, and they are our near neighbors, bound to us, traveling with us through the dark. And as they travel, they pull. Their gravity tugs gently but ceaselessly on the outer regions of our galaxy. And over hundreds of millions of years, that steady pull lifts and warps the disk. They draw long streamers of hydrogen gas out of the Milky Way, vast ribbons of it stretched across the sky, gas that astronomers have traced like the wake behind a slow ship. The galaxy and its companions are locked in a long, slow gravitational dance, and the warp in our disk is one of the visible signatures of that dance, written across 100,000 light years of space. There is something gentle in realizing this. The shape of our galaxy is not fixed and frozen, the way the schoolbook diagram suggested. It is responsive. It bends. It feels the presence of its neighbors and answers them slowly, over spans of time that dwarf anything we can imagine. The Milky Way is not a static object. It is a relationship, a conversation in gravity between a great galaxy and its small companions, played out so slowly that to us it appears perfectly still. And the flatness was not the only thing the diagram got wrong. The schoolbook drawing shows the arms as solid, permanent things, like the spokes of a wheel fixed in place forever. They are not. We will come to that later, to the surprising truth of what a spiral arm actually is. The diagram shows the edge of the galaxy as a clean, sharp line, a place where the galaxy simply stops. There is no such line. The galaxy fades outward into ever thinner scatterings of stars and gas, with no real border, no fence, no edge you could ever stand at and say, here it ends. And the diagram shows the whole thing as a single flat plate of stars, when in truth the disk has depth, layers, a structure top to bottom, that we will explore in the second act of tonight's journey. And consider the edge of the disk, which the schoolbook drew as a clean, definite rim, a place where the galaxy simply stops. There is no such rim. The disk does not end at a line. It thins. It frays. The bright, crowded inner disk gives way to ever sparser stars, and those give way to fainter wisps of gas, and the gas reaches farther still, flaring gently outward and growing thicker as it goes, like the bell of a trumpet, opening at its mouth. If you travelled outward from the centre, you would never cross a boundary, never pass a gate, never find a moment where you could say, here the galaxy ends and the emptiness begins. It would only grow quieter and thinner and darker by imperceptible degrees, until at last you noticed the stars had become very few and very far between. The galaxy has no shore. It simply fades, gently, into the dark, the way a sound fades, or the way the light fades at the end of a long evening, with no clean edge anywhere to be found. There is one more thing the schoolbook drawing quietly got wrong, and it is the way the galaxy turns. We tend to imagine it spinning the way a wheel spins, or the way a record turns on a turntable, every part going around together, the inner edge and the outer edge keeping perfect time. A galaxy does not turn like that. It cannot. The stars near the center, held tightly by all the mass packed around them, race around their small orbits relatively quickly. The stars far out near the edge swing around their enormous orbits far more slowly, so the galaxy does not turn as a single rigid thing. It shears. The inner parts lap the outer parts again and again over the ages, the whole disk slowly winding around itself, like cream stirred into coffee, drawing out into long curving ribbons. Astronomers call this differential rotation, and it is one of the deep reasons the spiral arms cannot be solid, permanent spokes. A rigid spoke would have wound itself into a tight, blurred knot billions of years ago. The arms must be something else, something that survives the endless winding. We will come to what they really are. For now, simply let go of the turning wheel, along with the flat circle, and picture instead a slow, shearing, ever-winding swirl, patient beyond imagining, turning differently at every distance from its heart. For now, it is enough to let the old picture go. The neat flat circle was a comfort, and a useful one, the way a simple map is useful, even when it leaves out the hills and the rivers. But the real thing is better. The real Milky Way is a warped and living disk, bent by the gravity of its companions, trailing ribbons of gas across the dark, turning slowly through a dance that began before the Earth was born and will continue long after tonight is forgotten. It is not tidy. It is not symmetrical. It is something far more wonderful than that. It is real. Here is a humbling thought to rest with for a moment. Every breathtaking image of our galaxy you have ever seen, every sweeping spiral of light that has been printed on a poster, or used as the cover of a book, or shown at the start of a documentary, every one of those images is, in some sense, a lie, a beautiful and well-meant lie, but a lie all the same. Because no one has ever seen the Milky Way from the outside. No human eye, no telescope, no spacecraft has ever looked back at our galaxy and seen its full spiral shape laid out the way those images show it. We never have, and in all likelihood, we never will. Think about what it would take to photograph our galaxy from above. The way those posters show it, you would have to travel up and out of the disk, far enough to see the whole spiral spread beneath you. But the galaxy is 100,000 light-years across. To rise far enough above it to capture it in a single frame, you would need to travel tens of thousands of light-years straight up out of the disk. Our fastest spacecraft, moving at their tremendous speeds, would need many millions of years simply to leave the neighborhood, let alone climb high enough to turn and take the picture. We are not going to do that, not in any time frame that means anything to us. We are, every one of us, born and living and dying inside the galaxy, with no way to step outside and look at it whole. There is an old image that captures our situation perfectly. Imagine a poet who has lived their entire life inside a single great cathedral, born in one of its pews, and never once permitted to step out the door. That poet might come to know the inside of the cathedral better than anyone alive. Every arch, every shadow, the way the light falls through the high windows at different hours. But the poet could never tell you what the cathedral looks like from the outside, never see its spires against the sky, its shape on the hill, its full form standing in the world. They could only infer it, slowly, patiently, from the inside. That is us. That is every astronomer who has ever lived. We are mapping the architecture of a cathedral we can never leave. And it is harder even than that, because we cannot even see clearly across the room we are standing in. Between us and the far side of the galaxy lies an ocean of dust. Not dust the way you think of it, the soft grey fluff under a bed. This is interstellar dust, made of unimaginably tiny grains of silicate, the stuff of sand and glass, and carbon, the stuff of soot, each grain smaller than the smoke from a candle. Thinly scattered, almost nothing, just a few of these grains in a great volume of space. But space is so vast, and the distance is so enormous, that across thousands of light years, all that thin dust adds up, and it does to starlight exactly what fog does to a streetlight. It absorbs it scatters it hides what lies behind. This is why, when you look up at the band of the Milky Way on a dark night, you see those dark rifts and channels running through it, places where the glowing river of stars seems to part and go black. For a long time, people thought those dark patches were holes, gaps in the stars, windows into empty space beyond. They are not holes. They are clouds, vast banks of dust hanging between us and the stars behind them, blocking the light. The galaxy is not dimmer there. It is hidden there. And because we sit inside the dusty disk, looking out through it in every direction, that dust hides the overwhelming majority of our own galaxy from our eyes. The great bright center of the Milky Way, with its billions of stars, is almost completely invisible to us in ordinary light, screened away behind curtain after curtain of dust. And the dust hides more than our own galaxy's heart. It hides whole other galaxies beyond it. Astronomers have a quiet, almost poetic name for the band of sky blocked by the disk of the Milky Way. They call it the zone of avoidance. It is the strip of the heavens, running along the line of our own galaxy's disk, where the dust is so thick that the galaxies behind it simply cannot be seen, where the distant universe is curtained off from us entirely. For a long time, that strip was a blank on our maps of the cosmos, a band of mystery where we knew there had to be galaxies and clusters and whole structures, and yet could see nothing at all. We were not only blind to most of our own galaxy, we were blind to a whole slice of the universe beyond it, hidden behind the same gentle veil of dust. Only with the longer wavelengths, with infrared and with radio, have we begun to peer into that hidden band and find what was always there: more galaxies, more structure, the universe quietly continuing behind the curtain. It is a humbling thing, and a beautiful one, to realize how much of everything has been kept from us simply by the dust of the very disk we live in, and how patiently we have had to work to see around our own home. For most of human history, that was simply the end of it. What the dust hid, we could not know. But here is where the story turns gently hopeful, because we found a way to see through the fog. Visible light, the kind your eyes use, is easily stopped by dust. But light comes in many forms beyond the narrow band our eyes can catch. There is infrared light, the light of warmth, with longer waves that slip past the dust grains almost untouched, the way the heat of a fire reaches you, even when smoke hides the flames. And there are radio waves, longer still, which pour through the dust, as if it were not there at all. We built eyes that could see in these other kinds of light, and when we did, the curtains parted. Through infrared and radio eyes, the hidden heart of the galaxy appeared, crowded and brilliant, exactly where the dust had told us nothing was. We began for the first time to map the true structure of the thing we live inside, not by seeing it from outside, which we will never do, but by patiently piecing it together from within, in light our own eyes cannot perceive, learning the shape of the cathedral from a single dusty pew. And this is the quiet miracle hidden inside the limitation. Every grand image of the Milky Way you have ever admired, since we cannot stand outside and photograph it, was built instead from the inside, star by patient star. Astronomers measure the distance to a star here, the motion of a star there, the glow of gas along a hidden arm, and they fold all of it together year upon year into a model of the whole. The beautiful spirals on the posters are not photographs. They are portraits, assembled from millions of careful measurements taken from our single fixed seat. The way a person locked in one room might slowly draw the whole house from the sounds and drafts and shafts of light that reach them through the door. The dust even leaves its fingerprints on the light that does reach us, and we have learned to read them. As starlight filters through the dust steals away more of the blue than the red, so distant stars arrive looking warmer, redder, dimmer than they truly are. The same way the setting sun turns amber as its light slants through the thick air near the horizon. By measuring exactly how reddened and how dimmed a star has become, astronomers can work out how much dust lies between us and it, and so map the invisible dust itself, turning the very thing that blinds us into another instrument for seeing. We do not just look past the dust, we have learned to read it. There is a strange comfort in this when you sit with it long enough. We are blind to most of our own galaxy, hidden from ourselves by dust, locked forever inside the very thing we are trying to understand. And yet we figured it out anyway. We are the cathedral, learning its own shape. We are the part of the galaxy that opened a new kind of eye and looked, finally, at the rest of itself. That is not a small thing. That is one of the quietest, most patient triumphs in all of human history. And we will return to how exactly we did it later tonight. Before we go any deeper, let us pause for a moment. We have come to the edge of the great ocean, and before we wade out into it, there is no harm in standing a while on the shore. So if your eyes are still open, you might let them close now. Nothing here needs watching. The pictures will keep. This part is just for listening, and for breathing, and for letting the day you have carried this far begin, finally, to set itself down. Take a breath, if you would like to. An easy one. In through the nose, slow, no effort, and then let it go, just as slowly, like a tide drawing back from sand. And then another, even gentler than the first. There is a rhythm to your breathing tonight, and there is a rhythm to the galaxy, and they are not so different. The galaxy turns. It does not rush. It has been turning for more than 13 billion years, one enormous patient revolution after another, and it has never once been in a hurry. You can borrow that pace for a while. You can let your breath fall into the same slow, unhurried turning in and out, like the wheel of stars overhead, going around and around in the dark. There is nothing you need to hold on to right now. The thoughts that came with you into this room, the small, unfinished things, the list that is never quite empty, you can set all of it down on the shore beside you. It will still be there in the morning if you want it. But it does not need you tonight. Tonight you are only a quiet passenger on a turning world, and the turning world is a quiet passenger on a turning galaxy. And the galaxy asks nothing of you at all, except that you rest inside it, which you are already doing, simply by being here. Feel, for a moment, how held you are. Beneath you, a planet, solid and ancient and certain, carrying you through space without the slightest wobble. Around that planet, a thin blanket of air, the only thing of its kind we know of anywhere, keeping you warm and breathing. Around all of it, a star, our sun, pouring out the steady light that has fed every living thing that has ever existed. And around the sun, the whole vast wheel of the Milky Way, holding the sun in a long, gentle orbit, the way a parent's arm holds a sleeping child. Layer upon layer of holding, all the way out. You are not adrift in the dark. You are cradled in it. And if you find, as we drift on through the night, that this slow journey through the galaxy becomes a place you would like to return to, a quiet corner of the night you can come back to whenever sleep is slow to arrive, then you are warmly welcome here any time. This is what we do on Cosmic Drift. We take the long, gentle way through the cosmos, one calm night at a time, so that your mind has somewhere soft to wander while the rest of you lets go. If you would like to drift through more nights like this one, you might quietly follow along, so the next journey can find its way to you. No need to do anything just now. Only know that the invitation is there, and it is offered the way everything here is offered, softly and without any hurry at all. Now, while you rest there on the shore, let me tell you where we are about to go, so that you can follow the shape of the night even with your eyes closed. We have looked at the size of our galaxy and at its true warped shape, and at the dust that hides most of it from us. That was the shore. That was the wide, calm water at the edge. Next, we are going to wade in. We are going to move through the anatomy of the galaxy itself, the great body of it, layer by layer. We will sink down through the thin disk, where the young stars live, and the old thick disk beneath it, where the ancient ones drift. We will travel inward along the great bar of stars that crosses the center, and we will come, gently and safely, to the strange quiet giant that sits at the very heart of it all. And then we will step back and meet the vast invisible thing that holds the whole galaxy together, the ghost that outweighs every star 100-fold and yet cannot be seen at all. None of it is frightening. That is the promise of this channel, and it is the promise of tonight. Even the black hole at the center, which the world loves to call a monster, will turn out to be, from where we sit, a calm and distant thing that has no interest in us at all. Even the dark matter, which sounds like something out of a nightmare, will turn out to be the very reason we are safe, the invisible arms that keep the whole galaxy from flying apart. There is nothing in the dark tonight that means us any harm. There is only structure and distance, and the slow, beautiful machinery of a galaxy turning, with us riding quietly somewhere inside it. If your thoughts wander while you lie here, and they will, that is perfectly all right. You do not have to chase them, and you do not have to push them away. Let them drift past the way the faint stars are drifting past, each one rising into view and then softening back into the dark, none of them needing to be held. The galaxy is patient with everything it carries, and tonight you can be just as patient with yourself. There is no part of this you can do wrong. There is no effort to make. There is only the slow turning, and your slow breathing, and the gentle understanding that you are exactly where you are meant to be, carried along, asked for nothing, held without condition in the vast warm dark. So stay where you are. Stay easy. Keep that slow rhythm in your breathing if it suits you, the in and the out, like the turning of the wheel, and let us wade out together, off the shore and into the body of the great galaxy that has carried us, without complaint, for 4.5 billion years. We begin with the layers of the disk, and the quiet difference between the young and the old. We are inside the disk now. This flat, glowing plain of stars is where almost everything you have ever seen in the night sky lives, and it is where we live too. But the disk is not a single sheet, the way it looks from far away. Drift close to it, the way we are drifting now, and you find that it has depth and structure and layers, like the layers of warm and cool water in a still lake on a summer evening. There is an upper region and a lower one, and they are not the same. They hold different kinds of stars, born in different ages of the galaxy's long life. Astronomers call them the thin disk and the thick disk, and the difference between them is, quietly, a story about time. Start with the thin disk, because that is where we are. The thin disk is the bright, busy, crowded layer, the narrow, bright line at the very middle of the disk. It is, in galactic terms, surprisingly slender. It reaches only about 1,000 light-years above and below the central plane, which sounds enormous, and is, but against a galaxy 100,000 light-years wide, it is thin as a sheet of paper laid across a dinner table, and it is the lively part of the galaxy. This is the nursery. This is where new stars are still being born, out of the gas and dust that pools in the thin disk, where the spiral arms gather their material and light their new suns. The stars of the thin disk are young, as stars go, and they are rich. Not rich in money, of course, but rich in what astronomers call metals, which is their slightly odd word for every element heavier than hydrogen and helium. Carbon, oxygen, iron, silicon, all the heavier stuff. These elements were not present when the universe began. They had to be cooked, slowly, inside generations of earlier stars, and scattered outward when those stars died. So a star rich in these heavier elements is, by definition, a star born late, after many earlier stars had already lived and died and seeded the gas around them. Our Sun is one of these. The Sun is a thin disk star, young and metal-rich, born in the fertile, well-stocked layer where the galaxy was still actively making things. We live in the lively part of town. But sink lower, drift down, out of that bright thin layer, into the fainter haze that surrounds it above and below. Here you enter the thick disk, and the feeling changes entirely. The thick disk is broader, puffier, reaching perhaps 3,000 light-years out from the central plane, 3 times the reach of the thin disk, and it is quieter, sparser. There is little gas here, little dust, almost no new stars being born. The thick disk is not a nursery. It is something more like a retirement home, or a library after closing, a place of old residence and long silences. The stars that drift through the thick disk are old. Some of them are nearly as old as the galaxy itself, formed in its distant infancy, when the universe was young and the heavier elements had barely begun to accumulate. And so these stars are metal poor, the opposite of our Sun. Many of them carry less than 1 part in 100 of the heavier elements our Sun holds. They are made almost entirely of the primordial hydrogen and helium that filled the early universe, with only the faintest trace of anything heavier. To look at a thick disk star is, in a real sense, to look at a fossil, a relic of the galaxy as it was billions of years ago, drifting on through the ages almost unchanged. There is something deeply moving in this when you let it settle. The galaxy keeps its history in its layers, the way a tree keeps its history in its rings, or a canyon wall keeps its history in its bands of stone. The thin, bright disk is the present, still being written, still making new stars and new worlds. The puffy, thick disk, wrapped around it above and below, is the deep past, the galaxy's own ancient memory, populated by stars that were already old, when the Earth was nothing more than a swirl of dust around a newborn sun. The 2 layers are not separate galaxies. They are the same galaxy, seen at 2 different depths of time, threaded through one another in the same volume of space. And the old stars move differently from the young ones. The young stars of the thin disk travel in neat, orderly, nearly circular orbits, all of them turning together in the same flat plane, like horses on a carousel all going the same gentle way. But the old stars of the thick disk move on wilder, more tilted paths, rising higher above the plane and plunging deeper below it, crossing the disk at steeper angles. They are not disorderly exactly, they are just old, and their orbits remember an earlier, more turbulent time in the galaxy's life. before everything settled into the calm, flat spin we know today. When you watch the thick disk move, you are watching the galaxy remember its own restless youth. We do not know with certainty how the thick disk came to be. There are gentle competing ideas. Perhaps it formed first, in the chaotic early days, and the thin disk settled out of cooling gas later, sinking into the middle, the way sediment settles to the bottom of a still pond. Perhaps the thick disk was puffed up by ancient collisions, smaller galaxies falling into the young Milky Way and stirring its stars to greater heights. Most likely it was some gentle combination of both, a story still being pieced together from the motions of millions of stars. But whatever the cause, the result is the home we live in, a layered disk, young at its heart and old at its edges, present and past folded into one turning structure. And there is one more layer, fainter and older than even the thick disk, wrapped around the entire galaxy like a vast, dim halo of light. Beyond the disk entirely, scattered through a great sphere that surrounds the whole Milky Way, drift the oldest stars of all, and with them, the globular clusters. A globular cluster is a tight, ancient ball of hundreds of thousands of stars, all bound together by their own gravity, all born together near the very beginning, when the galaxy was first taking shape. There are around 150 of these clusters circling our galaxy, and they are among the oldest things we know of anywhere, some of them nearly as old as the universe itself, 12 or 13 billion years. These ancient clusters and the lonely halo stars do not ride in the flat disk with us. They swarm the galaxy in a great rounded cloud, on long looping orbits that plunge through the disk and out the other side, rising high above the plane and falling far below it. They are the galaxy's elders, the survivors of its earliest days, and they keep their distance from the busy disk, drifting in slow, dignified arcs through the quiet halo. When we look out at them, we are looking at the deepest past our galaxy has, the first generation, still circling faithfully, long after the conditions that made them have passed away forever. And we, on our small blue world, ride in the thin bright present, the young and lively layer, born late enough to be made of the rich ash of 1,000 earlier stars. It is a good place to have been born. The heavy elements that built our planet and our oceans and our bones were only available because we arrived late in the fertile layer, after the galaxy had spent billions of years cooking them. But the thin disk is not the only great structure here. There is a backbone to this galaxy, a vast bridge of stars that crosses its very center, and it is to that we drift next. For most of the last century, when astronomers drew the Milky Way, they drew a simple spiral, a round center, and arms curling out of it. But as our eyes grew sharper, as we learned to see through the dust and map the motions of the stars in the crowded core, a different shape emerged from the center of our galaxy. Not a simple round hub, something longer, something with structure. Running straight through the heart of the Milky Way, like the crossbar of a letter, is an enormous elongated bridge of stars. Our galaxy is not a plain spiral at all. It is a barred spiral, and that bar is one of its grandest features. The bar is immense. It stretches something like 15 to 20,000 light-years from end to end, a structure so large that the entire distance from us to the galactic center, a journey light takes 26,000 years to make, is barely longer than the bar itself, and it is made, mostly, of old stars, cooler stars, yellow and orange and red, ancient residents of the galactic center, gathered into this long, glowing, cigar-shaped river of light that turns slowly through the middle of everything. if you could somehow rise above the galaxy and look down, the bar would be the first thing to catch your eye. A bright golden spine running through the center, with the spiral arms streaming away from its two ends like ribbons from the ends of a baton. For a long time we did not know it was there. From inside the disk, looking toward the center through all that dust, the bar is hidden, just as the rest of the core is hidden. It was only when we mapped the galaxy in infrared light, the light that slips through dust, and carefully measured the motions and positions of millions of stars in the central region, that the true shape revealed itself. The stars near the center were not moving the way they would in a simple round hub. They were moving the way stars move in a bar, streaming along its length, held in its elongated gravity. The shape was written in the motion, and once we learned to read the motion, the bar appeared. There was another clue too, and it came from simply counting. When astronomers used infrared telescopes to count the stars in the central regions of the galaxy, peering through the dust, they found something subtly lopsided. Looking toward one end of the bar, where it tipped slightly toward us, the stars appeared a little brighter and a little closer together. Looking toward the other end, tipped away from us, they seemed fainter and farther. A simple round bulge would have looked the same on both sides. This gentle asymmetry, brighter here, dimmer there, was exactly the fingerprint of a bar seen at an angle, one end leaning toward us, the other leaning away. Two completely different methods, the motion of the stars and the counting of them, told the same quiet story. We live in a barred spiral, and the bar is real, and it is enormous, and it has been turning through the center of our galaxy for billions of years. But the bar is not merely a shape. It does something. It is not a decoration lying still across the center of the galaxy. It is a working part of the galaxy's great slow machinery, and what it does is feed the heart. Think of the bar as an enormous gravitational conveyor belt. As it turns, its long gravity reaches out into the surrounding disk and gathers up gas, the raw hydrogen that drifts between the stars, and it funnels that gas inward, channeling it along the length of the bar and down toward the very center of the galaxy. The bar is a river, and gas is the water, and it flows slowly toward the core. And where that gas arrives, things happen. The inflowing gas piles up near the center, and where gas piles up and grows dense, gravity pulls it tighter, and new stars ignite. So around the inner end of the bar, near the galactic center, there are regions of surprisingly active star formation, rings and knots of new stars lit by the very gas the bar has delivered. The bar is, in a real sense, the galaxy's supply line, carrying fuel from the wide disk inward to the hungry center, keeping the heart of the Milky Way alive and active across billions of years. It is a quiet, patient act of feeding, performed by a structure 20,000 light-years long, turning once every few 100 million years. Bars like ours are common in the universe. A great many spiral galaxies have them, and astronomers think bars come and go over the long life of a galaxy, forming, strengthening, sometimes dissolving and reforming as the galaxy ages and its internal balance shifts. A bar is a sign of a certain maturity, a settled middle age in the life of a spiral galaxy, when the disk has grown stable enough and massive enough to organize itself into this grand central structure. Our Milky Way, with its well-developed bar, is a galaxy in a confident, productive prime, neither newborn nor dying, but turning steadily through the long middle of its existence. There is a strange comfort in the scale of it. We tend to think of the center of the galaxy as a single point, a place, a destination. But the heart of the Milky Way is not a point at all. It is this vast golden bar, longer than the distance from here to the core, a structure so large that our entire local neighborhood, every star you have ever learned the name of, would be lost as a single invisible mote somewhere out beyond its end. The bar does not know we exist. It has been turning and feeding the center and gathering its rivers of gas for billions of years, utterly indifferent to the small, warm world riding the quiet outer disk. And there is peace in that indifference, the same peace you feel standing at the foot of an ancient mountain. It was here long before you. It will be here long after, and it asks nothing of you at all. And the bar does something else, quietly, just by existing. Look at where the great spiral arms begin. They do not sprout from the round center at random. They trail from the two ends of the bar, one arm streaming off each tip, sweeping out into the disk in their long, graceful curves. The bar is the anchor, and the arms are the ribbons trailing from its ends as it turns. Our galaxy's grandest arms, the great Perseus arm on one side and the Sagittarius arm on the other, the very arms our own quiet neighborhood nestles between, can be traced back inward to where they join the spinning bar at the center. So the bar is not only a feeder of gas and a forge of new stars. It is the organizing spine of the whole spiral, the structure from which the arms themselves unfurl. When you picture the Milky Way now, picture that golden bar at the heart of it, slowly turning, with the two great arms streaming from its ends like banners in a slow and silent wind. We have traveled inward along the disk, down through its layers, and across the great bar to the center. And now there is only one place left to go, inward, past the crowded golden core, to the single strangest object in the entire galaxy, the thing that sits at the exact center of everything, around which the whole vast wheel quietly turns. It has a mass of millions of suns, and it is smaller than you would ever believe. We drift now to the heart of the heart, to Sagittarius A star. At the exact center of the Milky Way, at the still point around which the entire galaxy turns, there is a darkness, not an absence of stars. The stars near the center are packed more densely than anywhere else in the galaxy, millions of them crowded into a region that, on our scale, would hold only a handful. The darkness at the very center is something else. It is an object so dense, so concentrated, that not even light can climb out of it. It is a black hole, and not a small one. It is a supermassive black hole, and we have given it a name, Sagittarius A star. The name comes from the direction we find it in. When you look toward the constellation Sagittarius, low in the summer sky for those in the northern half of the world, you are looking toward the center of the galaxy and toward this object. Of course, you cannot see it. The dust hides it, and besides, a black hole gives off no light of its own. For most of the human history, we had no idea it was there at all. We only learned of it the way we learn of so much in the dark, not by seeing the thing itself, but by watching what it does to the things around it. And what it does is extraordinary. Over many years, astronomers watched a handful of stars near the galactic center, and they saw something that should have been impossible. These stars were not drifting slowly, the way most stars drift. They were racing, whipping around a single invisible point at tremendous speed, swinging in on long elliptical orbits, and then flinging back out year after year, decade after decade. One star in particular, on its closest approach, moved at thousands of kilometers every second. For a star to move that fast, to be held in so tight and so quick an orbit, there had to be something at the focus of those orbits with an enormous mass. Something invisible, something small, By measuring the orbits of those racing stars with great care over many years, astronomers weighed the unseen thing at the center, and the answer was staggering. About 4 million suns, 4 million times the mass of our own star, all gathered into a single object. And here is the part that genuinely strains the imagination. All of that mass, 4 million suns worth, is packed into a region of space smaller than the orbit of Mercury, smaller than the innermost loop of our own solar system. Imagine taking 4 million stars and compressing them all into a space you could tuck comfortably inside our solar system's smallest orbit. That is the density we are talking about. That is what sits at the center of the galaxy, holding those racing stars in their tight, swift loops. The work of measuring those orbits, of tracking those stars around the invisible center year after year, was so careful and so important that it was honored with a Nobel Prize. 2 teams of astronomers, working patiently for decades, followed those stars through their long orbits and proved, beyond reasonable doubt, that the heart of our galaxy holds a supermassive black hole. It is one of the great detective stories of modern science. Nobody ever saw the thing. They simply watched the stars dance around an empty point, and from the dance, they deduced the dancer. Now, here is where I want to set something gently to rest, because the words black hole carry such a weight of fear. Films and stories love to describe a black hole as a cosmic vacuum cleaner, a drain in the universe that sucks everything toward it, swallowing stars and worlds, pulling the whole galaxy slowly down into itself. That is not what is happening here. That is not what Sagittarius A star is doing. And understanding why is one of the quietest comforts in all of astronomy. A black hole's gravity is not special in its reach. It is just gravity, the same gravity the sun has, the same gravity the Earth has. What makes a black hole strange is only what happens very, very close to it, in the small region right at its edge. But step back even a little, and its pull behaves exactly like the pull of any object with the same mass. Here is the thought experiment astronomers like to offer. If you could magically replace our sun with a black hole of exactly the same mass, the Earth would not be pulled in. It would not even notice. It would keep orbiting in exactly the same path it follows now, at exactly the same distance, for exactly as long. The only difference would be the darkness and the cold. The gravity would be identical. A black hole does not reach out and grab. It only holds what comes close. And we are not close. We are 26,000 light years away from Sagittarius A star, far out in the quiet disk. From here, that 4 million sun black hole is a minor and distant presence. Its gravity, at our enormous distance, is gentle, just one small part of the great combined pool of the galaxy's hundreds of billions of stars, all of which together hold us in our wide, calm orbit. We do not orbit the black hole. We orbit the galaxy. The black hole is simply one resident of the crowded center, and from where we sit, it is no more a threat to us than a distant lighthouse is a threat to a ship far out on a calm sea. We feel its presence not at all. We circle on peacefully, indifferent to it, as it is indifferent to us. In fact, our Sagittarius A star is, as supermassive black holes go, remarkably quiet. Some galaxies have black holes at their centers that blaze with light, feeding furiously on great rivers of gas, pouring out radiation that outshines all the stars around them. Ours does not. Ours is calm, sedate, barely feeding at all, sipping only the thinnest trickle of material. It is a sleeping giant, mostly still, mostly dark, turning quietly at the center of the wheel. There may have been times in the deep past when it was more active, and there may be times in the far future when it stirs again. But tonight, and for all of human history, it has been a quiet heart, beating slow and low at the center of our galaxy, doing nothing more dramatic than holding the very innermost stars in their swift, small orbits. So let the fear go, if you are carrying any. The monster at the center of our galaxy is not a monster at all. It is a still, dark, immensely heavy thing, sitting calmly at the focus of everything. And from our safe and distant home, it touches us not in the slightest. We turn around the galaxy as a whole, held by all its gathered mass. And the black hole is just one small piece of that mass, far away, asleep. It is, if anything, the still center of a turning world, the quiet pivot at the heart of the wheel. There is nothing here to fear in the dark. There is only the slow, steady heartbeat of the galaxy, 4 million suns deep, beating once in the center, while the whole vast structure turns around it. And in recent years, we did something that would have seemed impossible to every astronomer who came before. We took its picture, not the black hole itself, which gives off no light and cannot be seen, but the glowing ring of hot gas swirling just at its edge, with the dark round shadow of the black hole sitting at the center of that ring. To do it, astronomers linked together radio telescopes scattered all across the Earth, from mountain tops to the South Pole, turning the whole planet into a single enormous eye, large enough to resolve something the size of that distant ring across 26,000 light-years of space. And when the image was finally assembled, after years of patient work, there it was, a soft orange circle of light with a dark heart, the actual silhouette of the supermassive black hole at the center of our galaxy. It is a strangely gentle image when you finally see it. Not a roaring monster, not a churning whirlpool of destruction, just a quiet, blurred ring of warm light around a still dark center, hanging calmly at the heart of the Milky Way. It looks, more than anything, peaceful. The most extreme object in our galaxy, photographed at last, turns out to look like a soft ring of candlelight glimpsed through fog. And it has been sitting there, exactly so all along, while we slowly built the eye that could finally see it. And yet, even all of this, the stars, the bar, the black hole, the whole glowing disk, is not the whole galaxy. Most of the galaxy by far cannot be seen at all. We turn now to the great invisible thing that surrounds everything we have looked at so far, the ghost that holds it all together. Everything we have looked at tonight, the disk of stars, the warped edges, the great bar, the black hole at the center, all of it together, the whole glowing spiral we call the Milky Way, is only a small part of what our galaxy actually is. The luminous spiral, the part that shines, the part we can photograph and admire and point to, is something like the visible tip of a far larger and stranger thing. It is a small, bright ornament, hanging at the center of an enormous, invisible sphere. And that invisible sphere outweighs everything that shines, many times over. We call it the dark matter halo, and it is, by mass, most of our galaxy. The name is honest about our ignorance. We call it dark matter not because it is sinister, but simply because it gives off no light. It does not shine, it does not glow, it does not block light or scatter it the way the dust does. It is, as far as our eyes and our telescopes are concerned, completely invisible in every kind of light we know how to see. It passes through ordinary matter almost without touching it. It may be passing through you gently right now. A thin rain of invisible particles drifting through the room, through the bed, through the earth itself, as though none of it were there. We cannot see it. We can barely interact with it at all. And yet we are certain it is there, because we can feel its gravity. The whole galaxy can feel its gravity. In truth, without it, the galaxy could not hold itself together. Here is how we know. When astronomers measured how fast the stars in the outer parts of galaxies were turning, they found something that should not have been possible. The outer stars were moving far too fast. According to everything we understand about gravity, a star way out at the edge of a galaxy, with most of the visible mass far inside it, should move slowly, the way distant Neptune orbits the Sun far more slowly than nearby Mercury. But the outer stars of galaxies were not moving slowly. They were racing around at high speed, fast enough that the gravity of all the visible stars and gas was nowhere near enough to hold them. At those speeds, with only the visible matter to hold them, those outer stars should have flung themselves off into intergalactic space billions of years ago, and the galaxy should have unraveled like a wheel spinning itself to pieces. But the galaxies have not unraveled. They are still here, still turning, still whole. And so there must be something else, something we cannot see, providing the extra gravity to hold those fast outer stars in their orbits. A vast reservoir of unseen mass, far more than all the stars combined, spread through and far beyond the visible galaxy. That unseen mass is the dark matter halo. It is the invisible hand that keeps the spinning galaxy from tearing itself apart, the deep gravitational well in which the bright spiral sits, safe and held, like a candle flame at the bottom of a vast, still cavern. And the halo is staggeringly large. The bright disk of the galaxy, the part that shines, is 100,000 light-years across, which we have already called vast. But the dark matter halo reaches far, far beyond that. It extends outward perhaps 300,000 light-years, and by some measures much farther still, plausibly toward 1,000,000 light-years in its faint outer reaches, a sphere so large that the entire glowing galaxy, the whole spiral we have spent this night exploring, sits like a small bright coin at the center of a darkened ballroom. By mass, this invisible halo makes up something like 85 to 90% of everything our galaxy is, which means the part we can see, every star, every nebula, every world, all the light there is barely 1/10 of the true Milky Way. The rest is dark and silent and unseen, and it is the larger part of home. It would be easy to find this unsettling, to feel that most of our galaxy is made of something we can't see or name or understand. But I would offer you the opposite feeling, because I think it is the truer one. The dark matter halo is not a threat. It is a cradle. It is the reason the galaxy is stable, the reason the stars do not scatter, the reason our sun has been able to hold its quiet orbit for 4.5 billion years without being flung off into the void. That invisible mass, whatever it turns out to be made of, is the deep foundation beneath everything that shines. The bright galaxy rides safely inside it, the way a city sits safely on the deep bedrock of the earth, unaware of the stone beneath it, held up by it all the same. There is a deeper role this invisible mass has played, one that reaches all the way back to the beginning. In the early universe, before there were any galaxies at all, the dark matter was already there, and being unable to give off light, it could cool and clump together more readily than ordinary matter. It gathered first, drawing itself by gravity into vast, invisible clumps and filaments, a great unseen scaffolding spread across the young cosmos. And then the ordinary matter, the hydrogen and helium gas, came flowing down into those dark wells, pooling in the densest knots, growing dense enough to ignite into the very first stars and galaxies. So the galaxies did not come first and gather dark matter around them. It was the other way around. the dark matter built the cradles, and the bright galaxies, including our own, formed inside them. We are, in a sense, the glowing sediment that settled into an invisible mold laid down at the dawn of time. And we can see the dark matter's gravity at work in another way too, beautiful and indirect. Its mass bends the path of light. When the light of a far distant galaxy passes near a great concentration of dark matter on its way to us, that light is gently curved, the way light bends passing through a lens, so the distant galaxy appears smeared, or stretched, or even multiplied into several images. By measuring exactly how the light is bent, astronomers can weigh the unseen mass that bent it, mapping the invisible by the way it warps the visible. We cannot see the dark matter, but we can watch it quietly bending starlight, and in that bending trace its hidden shape across the sky. We do not yet know what dark matter is. That is one of the great open questions of science, and it is a wonderful thing to have an open question this large still waiting to be answered. It may be some kind of particle we have not yet discovered, drifting cold and slow through space, clumping together by gravity alone into these enormous halos around every galaxy. Experiments deep underground, in quiet laboratories shielded from all other interference, are listening patiently for the faintest whisper of it, the rare gentle nudge of a dark matter particle against ordinary matter. So far, it keeps it secret. But we will keep listening. That is what we do. We are the part of the galaxy that learned to ask what the rest of it is made of. We do have gentle guesses about what it might be. The leading idea is that dark matter is some new kind of particle left over from the first moments of the universe that simply doesn't feel light at all, only gravity. There may be vast numbers of these particles streaming through everything, including this room, including you, so faintly interacting that trillions could pass through your body in a heartbeat and never touch a single atom. To try to catch even one, physicists have built exquisitely sensitive detectors and buried them deep underground, beneath mountains and in old mines, shielded from every other disturbance, waiting in perfect stillness for the rare, faint nudge of a passing dark particle. So far, the detectors wait in silence. Dark matter keeps its secret, but there is something beautiful in the patience of it. Scientists sitting quietly in the deep dark, listening for the softest possible whisper from the invisible majority of the universe, content to wait as long as it takes. We do not need the answer tonight. The question itself is a kind of wonder, and it will still be waiting gently in the morning. For tonight, it is enough to rest inside the knowledge that we are held. The galaxy we live in is far larger than it looks, and most of it is invisible, and that invisible majority is precisely what keeps us safe, the great dark cradle in which all the light is rocked. We sit at the center of a vast, unseen sphere, turning gently, going nowhere we were not always going to go, held by a hand we cannot see and have never needed to. There is no safer place to be than deep inside something that holds you completely. That faint point is us, and now that we have walked through the great body of the galaxy, it is time to find ourselves within it, to settle, at last, on the question the whole night has been quietly circling. Where, in all of this, are we hiding? We go now to our own address, the quiet suburb we call home. So here is the question we have been circling all night, the one folded into the title, the one I find the most quietly wonderful of all. Out of this entire galaxy, this 100,000 light-year wheel of hundreds of billions of stars, where exactly are we? Where is the sun? Where is the earth? Where is the small, warm world you are resting on tonight? And the answer, when you really sit with it, is one of the most comforting facts in all of astronomy. We are nowhere special, and being nowhere special is the best thing that could possibly have happened to us. We do not live at the center of the galaxy. We are not in the bright, crowded core, among the densely packed stars and the great bar and the supermassive black hole. And we do not live at the lonely outer edge either, in the thin and metal-starved fringes where the galaxy fades away into the dark. We live in between, about 26,000 light-years out from the center, roughly halfway between the core and the rim, in the suburbs, in the calm, spacious middle distance, where the stars are spread comfortably far apart and the great violences of the galaxy happen safely far away. If the galaxy were a great city, we would not live downtown, among the noise and the crowds and the bright lights, and we would not live out in the empty countryside beyond the last houses. We would live in a quiet residential street, somewhere in the gentle ring between the two. And that, it turns out, is exactly where life needed to be. Astronomers have a phrase for the comfortable middle ring, where conditions are kind to life. They call it the galactic habitable zone. It is the same idea as the habitable zone around a star, the narrow band where a planet is neither too hot nor too cold for liquid water, but scaled up to the whole galaxy. There is a band, a ring, within the galaxy, where the conditions for life are balanced just right. Too close to the center, and the trouble is severe. The stars are packed tightly there, which means supernovae, the violent deaths of massive stars, go off near one another far too often. It means bursts of radiation sweeping through space, and the constant gravitational jostling of close-passing stars, enough to disturb the gentle orbits a planetary system needs to stay calm across billions of years. The center is spectacular, but it is no place to try to keep a quiet world stable for the eons that life requires. But too far out, near the edge, and a different problem appears. Out there, the galaxy never gathered enough of the heavier elements. The far outer disk is poor in the metals we spoke of earlier, the carbon and oxygen and silicon and iron that are forged inside stars and scattered by their deaths. And those heavier elements are exactly what you need to build a rocky planet in the first place. Out at the thin edge, there simply was not enough of that material to make worlds like ours. So the outer fringe is starved of the very stuff that life is made from. And so we find ourselves in the kind middle, in the balanced ring, where there were enough heavy elements to build a rich rocky world with oceans and an iron core, but few enough nearby catastrophes to let that world sit undisturbed for the 4.5 billion years it took life to begin and grow and slowly become something that could look up and wonder where it was. Our address is not an accident in the sense of being lucky against the odds. It is more that life could really only have arisen somewhere like this, in the calm suburban ring. And so, of course, this is where we find ourselves. But knowing that does not make it any less beautiful. We live exactly where a world needs to live to become a home, and we have lived there quietly the whole time. And there is one more piece of quiet good fortune in our position, subtle and lovely. The spiral arms of the galaxy are not fixed objects. They turn as a pattern, sweeping around the disk at their own slow pace, while the stars orbit at theirs. In most of the galaxy, the stars and the arms move at different speeds, so a star is forever catching up to an arm, passing through its crowded star-forming lanes, then drifting out the far side, only to catch the next one later. But there is a special distance from the center, a particular radius, where the stars happen to orbit at very nearly the same speed as the spiral pattern itself. At that distance, a star keeps gentle pace with the arms, neither overtaking them often nor being overtaken, and so it crosses into their crowded, dangerous lanes only rarely. Our sun orbits surprisingly close to that quiet radius. We keep step with the spiral, more or less, which means we have spent far less time inside the busy arms, with their supernovae and their turbulence, than most stars do. It is one more way that our address has been kind to us, one more soft margin of safety we never had to ask for. There is a way to feel the gentleness of our position through time as well as through space. Our sun makes one full orbit around the center of the galaxy in something like 230 million years. Astronomers sometimes call that span a galactic year, one complete trip around the wheel, and it is a useful way to feel the depth of time. The last time the sun was in the position it occupies tonight, one full galactic year ago, the Earth was a very different place. There were no human beings, of course. There were no flowers yet blooming on the land. The great age of the dinosaurs had not even properly begun. The continents themselves were arranged into shapes you would not recognize, still drifting toward the map we know. An entire galactic year, an entire lap of the Milky Way, and in that one slow circuit, the whole story of the dinosaurs rose and fell. The continents wandered into their present places, and our own kind appeared, only in the very last sliver of the journey. And here is the gentle scale of that. Our sun, 4.5 billion years old, has made only about 20 of these galactic years in its entire life. 20 laps around the wheel in the whole time since it first ignited. The galaxy turns that slowly. Our orbit is that patient. We are not racing anywhere. We are drifting around the center on a circuit so vast and so slow that a single lap swallows the entire age of the dinosaurs and everything since. There is no hurry in our motion. There never has been. We are carried around the galaxy at a pace so calm that the rise and fall of whole worlds of life fits inside one quiet revolution. There is a lovely subtlety in how we move among our neighbors too. Astronomers sometimes speak of the local standard of rest, which is just the average drift of all the stars in our immediate neighborhood as they swing around the galaxy together. And relative to that gentle average, the sun is not perfectly still. We drift, very slightly, at a leisurely pace of a dozen or so kilometers a second, easing our way through the local crowd of stars, and we are drifting, as it happens, in the general direction of the constellation Hercules, slowly making our way toward that patch of sky across the ages. It is the faintest of motions, set against the great 220-kilometer sweep around the galaxy, like a passenger shifting gently in their seat on a train that is already racing across a continent. But it means that even within our quiet neighborhood, we are not anchored in place. We drift softly among the nearby stars, easing toward Hercules, carried along inside the greater carrying, motion within motion within motion, all the way down. There is a quiet, almost tender mystery folded into our address as well. Our sun was not born alone. Stars are born in groups, in great clusters of brothers and sisters condensing together out of the same cloud of gas. So somewhere, billions of years ago, the sun was born into a bright nursery of perhaps thousands of sibling stars, all formed from the same material, all kindled at nearly the same time. But the galaxy turns differently at every distance, slowly shearing, and over the long ages that gentle shearing has stretched our birth cluster out and scattered it all the way around the galaxy. Our siblings are out there still, somewhere drifting along their own orbits, carrying the same chemical fingerprint as the sun, the same trace of the cloud that made us all. We do not know which stars they are. Astronomers are only beginning to search for them, sifting through the data for stars that share the sun's exact composition. Somewhere in the great wheel tonight, our long-lost siblings are turning too, scattered far across the disk, quietly keeping us company across the whole galaxy without our ever having known. So this is our address, 26,000 light-years from the center, in the calm, habitable ring, on a slow and patient orbit that takes 250 million years to complete. Not downtown, not the lonely edge, the quiet suburbs, where life had room and time and stillness enough to begin. It is, when you hold the whole galaxy in your mind, a remarkably gentle place to have ended up. And it gets gentler still, because within this calm ring, we occupy an even smaller and even quieter pocket, a minor little side street of stars that has sheltered us from the worst the galaxy can do. That side street has a name, and it is one of the loveliest in all of astronomy. We go now to the Orion Spur. The galaxy's spiral arms are its grandest and most famous features, the great sweeping curves of light that give a spiral galaxy its shape and its name. And they are tremendous places, the arms, full of bright young stars and glowing clouds of gas, the most active and luminous regions of the whole disk. Our galaxy has several major arms, with names that sound like the constellations they lie behind. There is the Perseus arm, and there is the Sagittarius arm, two of the great major arms of the Milky Way, vast structures full of light and motion, and the constant business of making new stars. And here is the lovely thing about where we live. We do not live in either of them. We live in between. Tucked into the space between the great Perseus and Sagittarius arms is a smaller, fainter, more modest structure, a minor branch of stars that astronomers call the Orion Arm, or more affectionately, the Orion Spur. It is not one of the galaxy's grand major arms. It is a smaller feature, a kind of bridge or spur of stars threaded between the larger arms, perhaps 3,000 light-years across and 10,000 light-years long, a side street running quietly between two great avenues. And it is here, on this minor spur, away from the grandeur and the danger of the major arms, that our sun makes its home, along with most of the stars whose names you might know from a clear night. It takes its name from the constellation Orion, the great hunter of the winter sky, because many of the bright stars and glowing nebulae we see in that direction lie along this same local spur. When you look up at Orion on a cold, clear night, at the 3 stars of his belt and the soft glow of the great nebula below them, you are looking out along our own little branch of the galaxy, at our near neighbors on the same quiet street. It is, in a sense, the view from our own front porch, down our own road, before the road joins the great arms beyond. And the stars that share this spur with us are old friends, even if you have never thought of them that way. When you look up on a clear night and find the bright stars you know by name, you are very often looking at our neighbors on this same local branch. Brilliant Sirius, the brightest star in our night sky, lies just down the road from us, a near neighbor on the spur. Blue-white Vega and Altair, and the soft cluster of stars that make up the familiar shapes of summer and winter, are local residents of our own quiet neighborhood. Even the great red shoulder of Orion, the star Betelgeuse, glows from along this same spur, farther down our branch. The constellations you learned as a child are not scattered randomly across the whole galaxy. They are, overwhelmingly, the lights of our own small corner, the nearby houses on our own street, close enough to see clearly through the thin local dust. When you look up at the familiar sky, you are looking around your own neighborhood, at the porch lights of the stars who live nearest us on the Orion Spur. And this quiet address has been, very probably, one of the great unsung reasons that life on Earth had the chance to happen at all. Because the major spiral arms, for all their beauty, are dangerous neighborhoods. They are where the massive stars gather, the bright, short-lived giants that burn through their fuel in just a few million years and then die in supernovae, those tremendous explosions that flood the surrounding space with radiation. In the crowded major arms, supernovae go off relatively often, and a supernova close enough to a living world could strip away its protective atmosphere or bathe it in radiation, enough to end whatever was growing there. The arms are the galaxy's factories, magnificent and creative, but they are loud and bright, and from time to time, violent. Out here on the Orion Spur, between the arms, the stars are spaced more comfortably, the massive short-lived giants are fewer, and the supernovae are correspondingly rarer. Across the whole galaxy, a supernova goes off only a handful of times each century, and out here in our quiet pocket, the odds of one happening close enough to truly harm us are small, and have stayed small across enormous spans of time. Our spur has been a shelter, a calm harbor between two stormy coasts, and in that shelter, undisturbed, the Earth had the long, uninterrupted stretches of time it needed, billions upon billions of years of relative quiet, for life to take hold and slowly, patiently, become everything it has become, including us, resting here tonight, looking up. And here at last is the answer to a small mystery we left open earlier about what a spiral arm truly is. It is tempting to think of the arms as solid streams of stars, fixed strings of light swinging around the galaxy together. But we have seen that the galaxy shears as it turns, that any fixed pattern of stars would have wound itself into a blur long ago. So the arms cannot be permanent crowds. They are something subtler and lovelier. A spiral arm is a wave. It is a slow-moving region where stars and gas pile up and crowd together for a while, glowing brightly because the crowding triggers the birth of brilliant new stars, and then thin out again as the material moves on. The stars are not bound to the arm. They drift into it, linger in its bright crowded lanes, and drift out the other side, the way cars on a highway slow and bunch together at a traffic jam, and then ease apart and speed away once they are through. The jam itself stays in place, even though no single car stays in it. The arm itself persists, glowing, even though the particular stars within it are always changing. So our quiet spur is not only a calm address in space, it is a calm address in this slow traffic of the arms. We drift, for the most part, in the open road between the great crowded waves, easing into their bright, dangerous lanes only seldom, and passing through gently when we do. The arms sweep around the galaxy as slow waves of light and birth and death, and we, on our modest spur, keep mostly to the peaceful gaps between them, watching the great waves pass at a comfortable distance, never caught for long in the crowd. There is real gratitude to be felt in this, if you would like to feel it tonight. We did not choose our address. We did not arrange to be born on the quiet spur, in the calm, habitable ring, far from the crowded center and the violent arms. It simply happened that this is where the conditions were gentle enough, and so this is where we are. But the result is a kind of shelter so deep and so old that it is hard to take in. For 4.5 billion years, this small branch of stars has held our solar system in its calm embrace, keeping the worst of the galaxy at a safe distance, granting us the long, quiet stretches that let a planet of bare rock and water slowly fill with life. We are, in the most literal sense, sheltered. We have been sheltered the whole time, and we never had to do a single thing to earn it. And if this gentle picture of our place in the galaxy is the kind of thing that helps quiet your mind at the end of a long day, then let me offer the same quiet invitation I made earlier. Now that we have traveled this far together, and you know the shape of what we do here. On Cosmic Drift, every journey is like this one, slow and warm, and built to carry you gently off to sleep, while your mind wanders somewhere vast and calm and safe. If you would like more nights like this, you are welcome to follow along, so the next one can drift to you when you need it. There is nothing to do right now but rest. The invitation simply stays open, the way the porch light stays on. And now, let us settle back into the dark and keep drifting, because there is something surprising about the way our little corner of the galaxy is tilted, and it is lovelier than you might expect. Here is a small surprise about our place in the galaxy, the kind of detail that is easy to miss, but lovely once you notice it. We tend to imagine, without really thinking about it, that our solar system lies flat against the plane of the galaxy, that the sun and all its planets turn in the same flat sheet as the galactic disk, like a small wheel rolling along inside a much larger one, both lying level on the same great table. It is a natural thing to assume, and it is not true. Our solar system is tilted. It does not lie flat against the galaxy at all. It is set at a steep and rather dramatic angle to the galactic plane, and as we travel around the center of the galaxy, we are, in a sense, moving through it sideways. The plane in which the planets orbit the sun, the flat sheet that holds the Earth and Mars and Jupiter and all the rest, has a name. Astronomers call it the ecliptic, and the ecliptic is not aligned with the plane of the galaxy. It is tilted relative to it by a steep angle, something close to 60 degrees. 60 degrees is a large tilt. It is well past halfway to a right angle. So rather than lying flat in the galactic disk, our solar system is canted over at a steep slant, like a coin set leaning against the surface of a table rather than lying flat upon it. As we sweep around the galaxy, the flat plane of our planets cuts across the galactic plane at this sharp diagonal, the whole solar system tilted as it goes. There is a wonderful image that astronomers sometimes use to capture this, and it changes the way you picture our motion entirely. Forget the idea of a little wheel rolling neatly along a big flat road. Picture instead a spinning coin, set on its edge and tilted, sliding across a vast, smooth marble floor. The coin is our solar system, spinning, the planets going around the sun. The floor is the galactic plane, and the coin is not lying flat on the floor. It is tilted up at a steep angle, sliding along the great marble surface as it spins. That is closer to how we actually move. We are a tilted spinning thing, sliding along the grand level floor of the galaxy at a slant, year after year, lap after lap, never quite lying flat against the surface we travel across. It is easy to feel, when you first picture this, a small flicker of vertigo, the sense of being canted over at a strange angle in a way you never knew. But there is no need to. Remember that in space, there is no real up and no real down. There is no true floor and no true ceiling. The galactic plane is not actually a floor, and our tilt is not actually a lean, in any sense your body would recognize. These are just the geometries of motion, the angles at which two great flat structures happen to be set relative to one another, with no force pulling you toward either one. The tilt does not make you lean. It does not make the earth feel strange. You feel exactly as level and as settled as you always have, because there is nothing about the tilt that your senses could ever detect. It is simply a fact about the architecture of our motion. Beautiful to know, impossible to feel. And the tilt has a quiet consequence that you can actually see on any clear dark night if you know to look for it, because our planets orbit in the ecliptic, and the ecliptic is steeply tilted to the galaxy, the band of the Milky Way, and the path the sun and planets trace across our sky are not the same line. They cross. On a dark night, the soft glowing band of the Milky Way arches across the sky at one angle, and the line along which the sun, moon, and planets travel runs across it at another, the two great circles meeting at a steep crossing. You are seeing, with your own eyes, the tilt of our solar system against the plane of the galaxy, written across the night sky as two luminous paths set at an angle to one another. The geometry of our place in the galaxy is not hidden in textbooks. It is painted faintly overhead for anyone who lies back and looks. It is worth pausing on why we are tilted at all, because the answer is gentle and a little humbling. Our solar system formed 4.5 billion years ago from a slowly collapsing cloud of gas and dust. As that cloud drew together under its own gravity, it spun, and as it spun, it flattened into a disk, the disk that became the sun and all its planets. And the angle of that spin, the direction the whole cloud happened to be tumbling as it collapsed, was set by nothing more than the particular swirls and currents in that one small patch of the galaxy at that one moment. It had no reason to line up with the great plane of the Milky Way. Why would it? The galaxy did not reach in and tidy it, so our solar system simply settled at whatever angle its parent cloud happened to be turning. And that angle, frozen in from the very beginning, is the jaunty tilt we still carry today. We lean the way we lean because of how one cloud happened to be spinning long ago, and nothing has ever straightened us since. There is something I find quietly delightful in all of this. We are not arranged in the galaxy neatly, primly, flat against the plane like a well-set table. We are tilted. We are canted over at a jaunty steep angle, a spinning coin sliding sideways along the great floor of the Milky Way, cutting across the galactic plane on a slant as we go. It is a little bit whimsical when you think about it. The universe did not line everything up tidily. It let our solar system settle at whatever angle it happened to settle at billions of years ago, in the swirl of gas and dust that became the sun and its planets. And that slightly rakish tilt is simply ours now, the particular angle at which we ride. There is a kind of charm in being slightly askew. We are not flat against the galaxy, we lean. And we are not only tilted, we are moving all the time faster than any words can quite make real, even as we lie here in the dark feeling perfectly and entirely still. That is the last great strangeness of our place in the galaxy, and it is the one that brings us closest to the feeling at the very heart of tonight. We turn now to the speed of the ride, to the great cosmic carousel that carries us around the center of the Milky Way. We have arrived gently at the strangest and softest fact of the whole night, and it is the same one we began with. Return to now that you can feel the full size of what it means. You are lying still. You are as still as you have ever been, sinking into the bed, your breathing slow, the night quiet around you. And you are, at this very moment, being carried around the center of the galaxy at a speed that the human mind simply cannot hold. The sun, with the Earth riding alongside it, and you riding on the Earth, is sweeping around the galactic center at roughly 220 kilometers every second. Let that number settle slowly, because it does not feel like anything. 220 kilometers per second, not per hour, per second. In the time it takes you to read this one sentence, you and the Earth and the Sun have traveled more than 1,000 kilometers around the galaxy. In human terms, that is nearly 500,000 miles per hour. You are moving right now, faster than any spacecraft humanity has ever built, faster than any bullet, faster than nearly anything you could name, around an orbit so vast it takes 250 million years to complete. And you feel none of it. Not a breath of wind, not the faintest sense of speed, not a single drop of water trembling in a glass on the bedside table. This is the deepest version of the calm we started with tonight, and it is worth resting in fully. The reason you feel nothing is the same reason a passenger asleep on a smooth flight feels nothing, only carried to its grandest possible scale. When everything around you moves together perfectly at a steady and unchanging pace, the motion vanishes from your senses entirely. There is no jolt, because nothing is speeding up or slowing down. There is no wind, because the air moves with you. There is no sense of rushing, because everything you could compare yourself to, the ground, the house, the air, the moon, is all sweeping along at the same tremendous speed, in the same direction, in perfect company. The earth does not strain against this motion. It simply rides it smoothly, the way it has ridden it for 4.5 billion years, carrying every creature that has ever lived around the galaxy without a single one of them feeling the speed. A great cosmic carousel is the closest image I can offer you. You know the feeling of a carousel as a child, the gentle rise and fall, the slow turning, the world drifting past. Now make the carousel 250 million years wide and set it turning at 500,000 miles an hour, so vast and so smooth that the turning becomes invisible. And you are simply carried around and around in the warm dark by a machine so enormous and so gentle that it feels like perfect stillness. That is the ride you are on tonight. That is the ride you have been on every night of your life, and every night of every life before yours. The carousel never stops. It never jolts. It only turns, slow and smooth and tremendous, carrying its small sleeping passengers around the great wheel of the galaxy. And we are not even moving in a simple circle, not quite. The whole solar system, as it sweeps around the galaxy at this tremendous speed, is also drifting through the local sea of stars around it, the way a boat moves through water that is itself moving. The nearby stars are not fixed. They drift too, each on its own slow path around the galaxy, and we move among them, slowly changing our neighbors over millions of years. The stars that are near us now were not our neighbors in the deep past, and will not be our neighbors in the deep future. We are all of us adrift together, a great slow migration of stars around the galactic center. Our solar system, one small vessel in an enormous silent fleet, all sweeping the same way around the same vast center, all feeling perfectly still. And there is one more layer of motion underneath even the great galactic orbit, the deepest of all. Filling the entire universe in every direction, there is a faint and even glow left over from the birth of the cosmos, the cooled afterglow of the young universe soaking all of space. It makes a kind of universal backdrop, the closest thing there is to a still reference against which all motion can be measured. And when astronomers measure how we are moving against that ancient glow, adding up everything, the Earth around the sun around the galaxy itself drifting through space toward its neighbors, the total comes to something like 370 kilometers every second in one particular direction across the sky. 370 kilometers a second. That is our truest speed, our motion against the oldest light there is. And of course, you feel none of it, just as you feel none of the rest. It is simply one more current beneath you, the deepest one, carrying the whole galaxy and everything in it gently through the universe. You are nested inside motion within motion within motion. each one larger and slower and smoother than the last, and the sum of all of them, this great unfelt rushing through the ancient light, is as calm to your body as lying perfectly still in a quiet room, which of course is exactly what you are doing. There is a particular kind of peace available in this fact, and I would like to leave you resting in it before we move on. The motion that carries you is utterly beyond your control, and it always has been. You did not start it. You cannot stop it. You cannot feel it, or steer it, or hurry it, or slow it down. You can only be carried the way you have been carried your whole life, by a galaxy that has never once asked your permission and has never once let you fall. There is a deep restfulness in being carried like that. It is the restfulness of the passenger, not the driver. Tonight, you do not have to do anything at all. You do not have to hold the world up, or keep it turning, or manage its tremendous speed. The galaxy is doing all of that, smoothly, perfectly, as it has for billions of years. Your only task tonight is to lie still, and be carried, and rest. So we are tilted, and we are turning, and we are sweeping around the galaxy at 500,000 miles an hour through a slowly shifting sea of neighbor stars. And through all of it, we feel nothing but stillness. That is our motion. That is the ride. But the carousel does something else too, something even gentler than the great circle, a slow rising and falling that we have not yet spoken of. As we travel around the galaxy, we also bob softly up and down through its plane, like a wooden horse on the carousel, rising and falling as it turns. That gentle vertical drift is where we go next, into the final act of the night, and it is one of the most soothing motions in all the sky. We have one more motion to add to the others, and it may be the most soothing of all. As the sun carries us around the galaxy on that great 250 million year orbit, it does not travel in a perfectly flat circle, level with the galactic plane the whole way around. Instead, it bobs. It drifts gently upward, above the central plane of the disk, and then drifts gently back down, sinking through the plane and below it, and then rises again, over and over, a slow vertical wave threaded through the great horizontal circle. We do not just go around the galaxy. We undulate around it, rising and falling, like a horse on a carousel that lifts and drops as the carousel turns. The image of the carousel horse is almost exactly right. On a carousel, the horses do not simply go around in a flat circle. They rise and fall as they turn, lifting up and sinking down on their poles, tracing a gentle wave as the whole platform revolves. That is what our sun does as it travels around the galaxy. It rises above the disk, slows, sinks back down through it, passes below, slows again, and rises once more. A slow and graceful vertical dance laid over the great circular ride. And the reason is simple and gentle. The combined gravity of all the stars and gas in the disk is always softly pulling us back toward the central plane. When we drift above the plane, that gentle pull tugs us back down. We fall through, overshoot a little below, and the pull turns us around and lifts us back up. So we oscillate, rising and falling through the disk, held always by the soft gravity of the galaxy's own flat body. And this vertical bobbing has its own slow rhythm, its own quiet period. One full up and down cycle, rising above the plane and sinking back through it and returning, takes something like 60 million years. 60 million years for a single gentle rise and fall. So while the great horizontal orbit takes 250 million years, this softer vertical wave repeats several times within each lap. A slow dance nested inside the slower ride. We rise and fall, several times in each long circuit around the center, never straying very far from the plane, always drawn gently back, undulating quietly through the disk across tens of millions of years. And here is the gentlest detail of all, the one I most want you to rest on tonight. Where are we, right now, in this slow vertical dance? At this moment, the sun is not sitting in the middle of the galactic plane. We are slightly above it, something like 50 to 70 light years above the central plane of the disk, and, on the current best reckoning, we are still drifting gently upward, still in the rising part of the wave, still lifting slowly away from the plane before the soft pull of the galaxy eventually turns us around and draws us back down. And our little corner of the disk has its own gentle character, shaped by what came before us. The sun sits, at the moment, inside a vast region of unusually thin, warm gas, a kind of bubble blown clear in the interstellar medium long ago by the winds and the deaths of massive stars that lived and ended near here, before our own time. We are drifting through this cleared-out hollow, this quiet pocket of low-density space, on our slow rise through the disk. None of it disturbs us. The bubble is gentle, the gas within it sparse and calm. But it is a reminder that even our local neighborhood has a history, written by stars that blazed and faded in the deep past, leaving behind the soft cleared space we now drift through. We inherited a quiet room, swept clean by old fires that went out before we arrived. So tonight, as you lie there, you are not only being carried around the galaxy at 500,000 miles an hour, you are also, very slowly, rising, drifting upward, gently, through the disk of the Milky Way, on the long, slow swell of a wave that takes 60 million years to complete. There is something almost unbearably peaceful in that, when you let it in. You are rising. Right now, without any effort, without any sensation, without doing anything at all, you are being lifted, slowly and gently, upward through the great disk of the galaxy, on a swell so vast and so patient that across your entire life you will rise only the tiniest fraction of its arc. The wave that carries you took shape long before you were born and will go on long after you are gone. And tonight you are simply on the rising part of it, lifting softly through the dark, held by the gentle gravity of 100 billion stars, drifting upward the way a leaf drifts upward on a slow, warm current of air. In all the long history of the Earth, the sun has crossed back and forth through the central plane of the galaxy many times, dipping below and rising above again and again, on this same slow wave. And here is the reassuring part. Every one of those crossings was gentle. The disk is not a wall or a barrier or a hard surface to strike. It is only a region where the stars and gas grow a little denser, and we pass through it as softly as a swimmer, rising slowly through the surface of a calm lake, barely disturbing the water. The Earth has made this crossing over and over across its 4.5 billion years, and life has carried on through every one of them, undisturbed, the seas still rolling, the days still turning. The vertical dance is among the gentlest motions in all the sky, a slow rocking through a soft and yielding disk. Nothing struck, nothing jarred, only the long, easy rise and fall of a world being cradled through the ages. It is worth pausing to feel how slow this all is, because the slowness is the comfort. 60 million years for a single rise and fall. The last time the sun crossed the exact middle of the galactic plane, or reached the top of one of these gentle swells, the world was utterly different, populated by creatures long since turned to stone and memory. The rise you are on tonight will not complete for tens of millions of years more. long after every concern you carried into this room has dissolved entirely. There is nothing in this motion that you need to track, or worry over, or even notice. It is simply happening, slowly, beautifully, all around you and through you. The gentlest possible motion laid over the great calm ride of the galaxy. You are rising and falling and turning all at once, and all of it feels exactly like lying still. This is the dance we are all in, every star in the disk, all of us rising and falling through the plane on our own slow waves, all of us turning around the center together, 100 billion quiet horses on the grandest and gentlest carousel there has ever been. The galaxy holds us all in this soft, undulating motion, and it has held us so for billions of years, and it will hold us so for billions more, drawing us gently back whenever we drift too far, never letting any of us fall, never letting any of us fly away. We are rocked. That is the truest word for it. We are rocked slowly through the disk of the Milky Way, on a wave 60 million years long, like a cradle that takes an age to swing. So that is the full shape of our motion at last. We turn around the galaxy. We sweep through a sea of drifting neighbor stars. We lean at a jaunty tilt against the galactic plane, and we rise and fall through that plane on a slow 60 million year wave, rising even now, gently, in the dark. All of it together, and all of it felt as perfect stillness. It is one of the great quiet gifts of being alive on this small world, to be carried through such tremendous and complicated motion so smoothly that it feels like rest. But we could only learn any of this, could only know that we rise and turn and lean and drift, because of the long and patient work of the people who looked up and tried to measure it. And before we make our final landing into sleep, I would like to honor them, the human watchers, the ones who mapped a galaxy from the inside. Everything we have drifted through tonight, the size of the galaxy, its warped disk and layered thickness, the great bar, the black hole, the dark halo, our quiet address on the Orion spur, our tilt and our turning and our gentle rise and fall, every piece of it, we know only because human beings locked inside this galaxy with no way to step outside and look, decided to figure it out anyway. They had no view from above. They had no map. They had only the points of light overhead and the patience to study them, night after night, year after year, lifetime after lifetime. And slowly, impossibly, from inside the cathedral, they worked out its shape. It is one of the quietest and most beautiful achievements of our species, and it is worth resting in before we close our eyes. Go back to the 1700s, to a brother and sister working together in England under the night sky. William and Caroline Herschel. William built his own telescopes by hand, grinding the mirrors himself, until he had instruments better than almost any in the world. And Caroline worked beside him, recording his observations, doing the long, careful calculations, and becoming a remarkable astronomer in her own right, discovering comets and cataloguing the sky. Together, night after night, they did something that sounds almost impossibly simple and was, in fact, a stroke of quiet genius. They counted stars. They pointed the telescope in direction after direction across the sky, and patiently counted how many stars they could see in each one, trying to map, from the counts, the shape of the system of stars we live in. Their map was wrong, in the end, in ways they could not have known. They had no idea about the dust that hides most of the galaxy, so they could not see that their counts were being cut short by darkness they could not detect. They placed the sun near the center, because in every direction the dust made the star counts fall off at roughly the same distance, giving the false impression that we sat in the middle of things. They could not have known better. But that is not the point. The point is that they tried. They stood inside a galaxy 100,000 light-years wide, with a hand-built telescope and a candle and a ledger, and they set out to map the entire thing by counting its stars one by one. That impulse to measure the unmeasurable, to map the thing you are lost inside, is the same impulse that has carried us all the way to tonight. But before we reach the modern spacecraft, there is one more figure who deserves a quiet word, because without her, much of what followed would have been impossible. Her name was Henrietta Leavitt, and in the early 1900s, she worked at Harvard, patiently studying photographic plates of the sky, measuring the brightness of thousands of stars by hand, and she noticed something in a certain kind of star, a type that pulses, slowly brightening and dimming over days or weeks. She found that the slower a star pulsed, the brighter it truly was, in a precise and dependable relationship. It sounds like a small thing. It was one of the most important discoveries in the history of astronomy, because once you know how bright a star truly is, you can tell how far away it must be from how dim it appears, the way you can judge the distance of a candle if you know exactly how brightly it burns. Leavitt had handed astronomy a ruler for the cosmos. It was that very ruler that Edwin Hubble picked up a little over a decade later, when he found one of these pulsing stars in the faint smudge of Andromeda and used it to prove that Andromeda lay far beyond our own galaxy, a separate island of stars in its own right. The quiet measurements of one woman at a desk became the foundation under our entire map of the universe, and around the same time, another quiet accident opened a second new window. An engineer named Karl Jansky, trying to track down a faint hiss interfering with radio signals, realized the hiss was coming from the sky, strongest in the direction of the galactic center. Without meaning to, he had heard the Milky Way itself, in radio waves, and founded the science that would one day let us map our galaxy straight through the dust. Step by patient step, plate by plate, hiss by hiss, we built the tools to measure a galaxy from the inside. Now leap forward across the centuries, past generations of patient astronomers, each one adding a little more to the map, until you arrive at our own time, and at a spacecraft named Gaia. Gaia was launched in 2013 by the European Space Agency and sent out to a quiet point in space far beyond the moon, where it has spent years doing the Herschel's work, raised to a scale they could never have dreamed of. Gaia spins slowly and steadily, turning all the way around about once every 6 hours, sweeping its instruments across the whole sky again and again. And as it spins, it measures the stars, not just their brightness, but their exact positions, and the tiny, almost imperceptible shifts in those positions as the spacecraft and the Earth move through space. The precision of it is difficult to take in. Gaia carries a camera of nearly 1 billion pixels, the largest ever flown in space, and with it, it measures the positions of stars so exactly that it can detect shifts in angle finer than almost anything you could imagine. The apparent width of a small coin, seen from across an ocean. By measuring how a star appears to shift its position ever so slightly as the Earth moves from one side of its orbit to the other, Gaia can calculate the distance to that star with extraordinary accuracy, a technique built on the same simple geometry that lets your 2 eyes judge how far away something is. And it has done this not for a handful of stars, but for almost 2 billion of them. Almost 2 billion stars. Gaia has mapped the precise positions, distances, and motions of nearly 1.8 billion stars in our galaxy, the most detailed and accurate map of the Milky Way ever made. It is from Gaia's patient measurements that we have learned so much of what we drifted through tonight. The warp in the disk, the slow streams of stars from ancient swallowed galaxies, the gentle motions that reveal the dark matter's pull. And here is the detail that brings the whole night full circle, that holds the scale of the galaxy in a single quiet fact. Even after mapping nearly 2 billion stars, the most ambitious star mapping mission in history, Gaia has charted only about 1% of the stars in the Milky Way. 1%. The other 99% remain uncounted, too faint or too distant or too hidden by dust, stretching away into a galaxy so vast that even our greatest map captures only the nearest hundredth of it. Sit with that for a moment gently, because it holds both halves of tonight's paradox in a single image. We have made the most precise and most ambitious map of our galaxy in all of human history, a map of nearly 2 billion stars, built by a spinning machine 1 million miles from Earth, refining the work the Herschels began with a candle and a ledger 3 centuries ago. And that magnificent map, that crowning achievement, covers 1% of home. The galaxy is so large that our greatest effort to measure it has touched only the nearest sliver. And yet, we made the map. From inside the cathedral, blind to most of it, locked in forever, we built an eye that could see nearly 2 billion suns and place each one in space. That is who we are. We are the small, patient, persistent thing that maps the vastness it is lost inside. One star at a time, across the centuries, never finishing, never stopping. So as you lie there tonight, carried around the galaxy you can never leave, know that you are the inheritor of all that looking. Every fact that has soothed you tonight was a gift, handed down across generations of people who stood in the dark and refused to stop asking where they were. They will never know that you rested easier for their work, but you can rest easier for it all the same. We are held by the galaxy, and we are held too by the long, patient chain of watchers who mapped it. And tonight, you can let both of them carry you. There is just a little further to drift now, gently downward, towards sleep. 2 last quiet thoughts, and then we let the lights go all the way down. There is one last quality of the galaxy I would like to leave you resting in, and it is, perhaps surprisingly, the emptiness. When we picture the galaxy, we tend to imagine the stars crowded close, a glittering throng of light, shoulder to shoulder across the sky. The images encourage it, all those photographs where the stars pile up thick and bright. But the truth of our galaxy, the deep truth of it, is that it is mostly empty, mostly quiet, dark, open space, with the stars scattered through it so thinly, so far apart, that the distances between them dwarf the stars themselves almost beyond comprehension. The Milky Way is not a crowd. It is a vast, calm, nearly empty cathedral, with a few candles set very, very far apart. Here in our part of the galaxy, the typical distance from one star to the next is something like 5 light years. 5 light years between neighbors. Remember what a light year is. The distance light travels in a year, moving at the fastest speed there is. Our nearest neighboring star, Proxima Centauri, is a little over 4 light years away, and it is one of the closest stars to us in the entire galaxy. And yet, to reach it, our fastest spacecraft would need tens of thousands of years. That is the gap to our nearest neighbor. And across most of the galaxy, the gaps are like that, or larger, vast oceans of empty space between one quiet island of light and the next. It is genuinely hard to feel how empty that is, so let me offer you an image to hold. Imagine you shrank the sun, our enormous star, more than 1 million kilometers wide, all the way down to the size of a tennis ball, a small thing you could hold in your hand. On that scale, how far away would the nearest other star be? not across the room, not down the street, not even in the next town. On that scale, with the sun shrunk to a tennis ball resting in a city like New York, the nearest neighboring star would be another tennis ball, sitting hundreds of miles away, somewhere down near Atlanta. 2 tennis balls, one in New York and one in Atlanta, with nothing at all between them but empty air for hundreds of miles. That is the true emptiness of our galaxy. That is how thinly the stars are spread. 2 small balls, an entire region apart, and that is the close neighborhood. And because the gaps are so wide, the light itself is always old by the time it reaches you. When you look up at a star tonight, you are not seeing it as it is. You are seeing the light it sent out years ago, sometimes many years ago, crossing all that empty space to arrive at your eye only now. The starlight that touches you tonight set out across the dark while you were doing something else entirely, or before you were born, or in some cases before any human being walked the earth. Every point of light in the night sky is a small message from the past, carried faithfully across the vast empty between, arriving gently, at last, at a pair of open eyes. There is something tender in that. The night sky is not a picture of how things are. It is a picture of how things were, assembled from countless different moments in the past, all the old light arriving together to make one quiet, glittering present. Now, the word empty can sound sad, or lonely, or cold, but I would like to turn it gently the other way, because I think the emptiness of the galaxy is one of the most comforting things about it. That immense spacing between the stars is exactly what keeps our home so calm and so safe. Because the stars are so far apart, they almost never collide. They almost never even come close enough to disturb one another. Our sun has sailed through the galaxy for 4.5 billion years, around and around, rising and falling through the disk, and in all that time, it has never once come close enough to another star to disrupt the gentle orbits of its planets. The vast empty space around us is not a void to fear. It is a buffer. It is breathing room. It is the wide, quiet margin that has kept our solar system undisturbed across almost the entire history of the Earth. Think of it as the difference between a house in a crowded city block, with neighbors pressed against every wall, and a house alone in a vast, quiet meadow, with the nearest other home miles away over the hills. Our solar system is the house in the meadow. The space around us is enormous and silent and almost entirely empty, and that emptiness is precisely why it has been so peaceful here for so long. Nothing comes close. Nothing intrudes. The Earth has had billions of years of undisturbed quiet because we live in one of the emptiest, most spacious kinds of place there is, a thin scattering of stars in an ocean of gentle dark. And the emptiness only deepens as you pull back. Just as the stars are scattered thinly through the galaxies themselves are scattered thinly through the universe, gathered along faint threads and sheets with enormous dark spaces between them. These great empty spaces, the cosmic voids, are so vast that a single one of them could hold our entire local group of galaxies many times over with room to spare. And yet inside them there is almost nothing at all, just the deep quiet of nearly empty space stretching for hundreds of millions of light years. The universe, on every scale you choose, turns out to be mostly gentle emptiness. Thinly scattered stars in a mostly empty galaxy. Thinly scattered galaxies in a mostly empty cosmos. Quiet and spacious and calm, all the way up and all the way down. And rather than making us feel lost, I think there is a deep peace waiting in this, if you let it settle over you tonight. We so often imagine the universe as crowded, busy, full to bursting. It is the opposite. It is overwhelmingly open overwhelmingly spacious, overwhelmingly still. There is so much room out there that the mind can hardly hold it. And we are floating gently in one small warm pocket of all that vast and peaceful openness, with nothing pressing in, nothing crowding close, only the soft dark spaciousness of a universe that is, above all else, calm. And there is a stillness you can borrow from this, lying here tonight. The galaxy is not crowding you. It is not pressing in. It is opening out around you, vast and quiet, and almost entirely empty. The nearest star an unimaginable distance away, the next one farther still. All of it spread so thin and so wide that our whole solar system floats alone in a great calm darkness, untouched, unhurried, undisturbed. There is so much room. There has always been so much room. You are not packed into the galaxy. You are cradled in the middle of an enormous, gentle emptiness, with nothing near enough to trouble you, nothing close enough to so much as cast a shadow. The vast empty between is not loneliness, it is safety. It is the deep quiet space that has let everything here, including you, exist in peace. So this is the galaxy we have drifted through tonight, in all its true scale and shape. A vast warped disk of a few 100 billion stars, layered young over old, crossed by a great golden bar, anchored by a quiet black hole, cradled in a dark invisible halo many times larger than all the light, a galaxy that is one of the giants of the universe and also against the cosmos, a speck, and our place within it, the answer to where we are hiding, is now as clear and as gentle as the rest. We are far out in the calm suburban ring, on a quiet minor spur between the great arms, leaning at a jaunty tilt, turning slowly around the center, rising softly through the disk, floating alone in an ocean of empty space so wide it has kept us safe since before the earth had life. There is one last thing to say about all of it, the simplest and the truest thing, and then we can let the night close over us completely. So here is where we have arrived, at the end of the long drift, with the whole galaxy laid gently out behind us. And the truest thing to say about all of it is also the simplest. We are not lost. For all the vastness we have traveled through tonight, all the 100,000 light years and the hundreds of billions of stars and the invisible halo reaching toward 1,000,000 light years out, we are not lost in any of it. We are placed. We are exactly, precisely placed in one of the gentlest and safest corners the galaxy has to offer, and we have been placed there, quietly, the entire time. Let the whole picture settle over you now, like a blanket drawn up at the end of the day. We are nestled in the quiet suburbs of the Milky Way, 26,000 light years from the bright and crowded center, far from its violence and its noise. We are sheltered on a small minor spur of stars, the Orion spur, tucked safely between the great spiral arms where the supernovae bloom, kept at a calm distance from nearly all of them. We are floating alone in a vast emptiness so wide that no other star has come near us in the entire history of the Earth. We are turning gently around the galaxy at a pace so slow that a single lap holds the whole age of the dinosaurs and everything after. And we are rising, even now, softly, on a slow wave through the disk, rocked like a cradle that takes 60 million years to swing. None of this is new tonight. That is the gentlest part. The galaxy has been holding us exactly like this for 4.5 billion years. Long before there were any eyes to see it, long before the first living thing stirred in the first warm sea, the Earth was already here, already turning around the sun, already being carried around the galaxy on this same calm and stable path, rising and falling through the disk on the same slow wave. The path that carries you tonight is older than life itself. It held the first cells and the first forests and the first creatures to ever look up at the stars. It held everyone who has ever lived and everyone you have ever loved. And it is holding you now, exactly as steadily, exactly as gently, asking nothing of you at all. And it will keep holding us long after tonight. When you wake tomorrow, the galaxy will have carried you a little further along its great orbit, lifted you a little higher on the slow wave, and you will not have felt a thing. When the morning comes and the small concerns of the day return, the galaxy will still be turning beneath them, steady and patient and unbothered, the way it has turned through every morning and every worry there has ever been. It is in no hurry. It has been here for 13 billion years, and it will be here for billions more, turning slowly in the dark, holding its small warm worlds along their quiet paths, whether or not anyone is awake to notice. Think for one last gentle moment of everything that is holding you tonight. A planet beneath you, ancient and steady, turning without a sound. A star nearby, faithful, pouring out its warmth as it has for billions of years. A quiet spur of stars, sheltering us between the great arms. A vast disk, cradling us as we rise and fall on our slow wave. An invisible halo, wider than all the light, holding the whole galaxy gently together. And beyond even that, a universe so spacious and so calm that our every motion through it feels like perfect stillness. Layer upon layer upon layer of holding, reaching all the way out into the dark, and every single layer of it has been here, doing exactly this, since long before you were born, and will go on doing it long after tonight has slipped away into morning. So you can let go now. There is nothing left to hold. The earth is solid beneath you, and it is not going anywhere it has not always gone. The sun will rise on schedule, carried by the same orbit that has never once faltered. The galaxy will keep you exactly as safe tonight as it has kept everything that has ever lived, in the calm suburb, on the quiet spur, in the vast and gentle emptiness, rising slowly through the disk in the dark. You do not have to do anything to stay safe here. You never did. You only have to rest, and let the great wheel turn, and let yourself be carried, the way you have been carried your whole life, by something far larger and far kinder than it ever looked from below. You are a small, knowing part of something vast and old and quiet. You are made of its very atoms, the iron and the oxygen and the calcium forged in its stars, gathered for a little while into someone who can look up and understand where they are. And tonight, that someone can rest. The looking is done for now. The map can wait. The galaxy will hold its shape until morning, and so will you. There is nothing above you but the slow turning canopy of stars, and nothing beneath you but a steady world on an ancient and faithful path, and nothing required of you at all but to close your eyes and breathe and drift and let the long night carry you the rest of the way down. Sleep now. The galaxy is turning. You are held, and you are exactly where you have always wanted to be hiding, in the quiet suburbs of a great wheel of light, safe in the vast and gentle dark.